In Algebra 1, section 9.3, we're dealing with exponential growth and decay. So the exponential functions we're using specifically in order to find, when we're dealing with money, when you're depositing money, or when you buy something, a big purchase, you have exponential decay. Exponential growth is when you invest and it increases. When we're trying to predict population. Now, some of you guys haven't had a lot of, experience with predicting population, but it is important for us to be able to predict so that countries can prepare for how much schooling is needed, how much, supplies, how much taxes they're going to get. All that stuff depends on the population, how many people. So these are important functions for us to understand. And you're not going to have to memorize them for the test, but I will need you to be able to be familiar with them and understand what letters represent what and what to plug in. So exponential growth shows a graph that increases exponentially. So there's bound to be an exponent in it. The letter Y is your final amount. Okay, that's usually the answer that we're looking for. The rate in decimal is R. Okay, sometimes I'll give you in percentages for the rate, but in order for you to put it into the calculation, it has to be in decimal. And remember, in order for you to put a percentage in decimal, you just divide it by 100. Your original amount is what you start off with. So let's say you invest a certain amount, and then the bank gives you, interest for letting you have their money, letting them have your money. So that would be the original amount that's put in, or the original population. And then you apply everything to get the final. And T would be the time. For exponential decay is the same equation, as you can tell, except instead of adding the rate as it increases, you're subtracting the rate as it decreases. Compound interest is if the interest is applied more than once in a year. So for example, if something is, if you're gaining something maybe once a month, then it would be compounded 12 times in 1 year. So everything is the same. These are the same, but these letters slightly change. So you have your A, which is your balance after however many years you're looking for. P would be the principal amount. R would be the annual interest rate. And again, the rate needs to be in decimal. Okay, that R. N is the number of times interest is compounded. So basically when I said talking about once per month, that would be 12 months in a year, so your N would be 2. If it's biannually, let's say it's twice a year, then you would put 2 for N. And then your T would be how many years. Half-life is something that we deal with when it comes to exponential decay. It's kind of comparing two different things that are decaying to see how old one is compared to the other. And this equation is A equals P 0.5 to the power of T. Same lettering as here. P stands for your original, T stands for your time. Now, please make sure that you realize the order of operations. When you are solving these problems, the parentheses goes first, and then you apply the power, and then you multiply the number in front. It's going to be very tempting to multiply A in whatever this is, but then you'll get a completely wrong answer. All right? So go ahead and write this down, and we're going to do some example problems on the board. Okay, so number 1 states that the original value of a painting is $9,000 and the value increases by 7% each year. Find the painting's value of 15 years. So your first step is to figure out which of the equations that we're going to be using. All right? So if this says that it's increasing, okay, it's not increasing, it's not compounded annually. If it says compounded annually, then we're going to use the compound interest. But because it's just increasing, we're going to stick with exponential growth. And the equation for exponential growth is y equals a 1 plus rt. So let's find all our letters first. Y is what we're looking for. Okay? So a would be our original amount, so that would be 9,000. Our R would be our rate, and this is 7%, but we're looking at in decimals, so I'm going to divide 7 by 100, that gives me 0.07. That's very important because you'll have a very different number. And then my T would be, I want to find out how much I end up with in my investment after 15 years. So let's plug that all in. Remember, just like all the other problems, I can only solve if there's a maximum of one missing variable. So let's see if that's the case. Y is unknown, 9,000, 1 plus R, no, 1 plus 0.7, 15. Perfect, just one variable. We end up with 9,000, 1 point, oh, this is supposed to be 0.7. Okay, so order of operations, we're going to do the inside first. So 1 plus 0.7 is 107 to the power of 15. So this is one of those things where it's going to be tempting to first multiply these, but no, the powers make us, says we have to do that first. So we're going to do 1.07 to the power of 15. So I end up with 9,000, because I have to carry that 9,000, times this to the power of 15 is 2.759. Try to use at least 3 or 4 decimals in this case, because the more I use, the more accurate my answer is going to be. And we're going to do times times 9,000, which would give me 81.28. Okay? So this means that if I were to buy a painting at $9,000, and in each year that painting increases 77%, in 15 years, I'm going to end up with $24,831.28. Can you imagine then if you could find at least 2 or 3 paintings, put the money down, you could potentially in 15 years pay for a college education. Number 2, $15,000 invested at a rate of 4.8% compounded monthly. Find the amount in 2 years. Here is our keyword. Dun, 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 compounded monthly. What that means is if it's compounded monthly, it means that we're going to be using compound interest. Okay? So the equation for compound interest is A equals P 1 plus R over NT. No, NT. So let's find the values of this. A is our amount that we're looking for. Our original amount P would be 15,000. My R would be my rate, 4.8. Don't forget to please put this in decimals, so I'm going to divide that. So I'm going to put 0.048 divided by 100. That's how I got this. I took this and divided it by 100. And then my N is how much is compounded in a year. Well, if it's compounded monthly, that means every month the interest is compounded. So that gives me 12 times, because there's 12 months in a year, 12. And my time I'm looking for is 2 years, how much I'll have in 2 years. So if you invest $15,000 at a rate of 4.8%, okay? So, you know, the bank needs you to have that, needs to have money. People store their money so they can loan out money and they can make money on the the money they loan, but they need your money, if that makes sense. Sorry about that. So they will give you, a certain interest on it. So the bank, let's say, if they say, give us $15,000, and every month we'll give you 4.8, we'll increase it by 4.8%, which 4.8 doesn't seem big, but it does if it's compounded monthly. So let's see how much money you're going to make after 2 years. Is it worth it? Okay, let's see. A's we're going to leave, because that's what we're looking for. We're looking for that final amount. We have 1,500, yes. 1 plus R, which is 0.48 over, 0.08 over 12, 12 times 2. All right. So let's work from the inside out, okay? Don't just plug this all in your calculator. Take it one step at a time and show all your work. Let's start with 0.048 divided by 12. 0.048 divided by 12. This is 1.123. Okay. And then 12 times is 24. So that gives us 1,500, 1.004 to the power of 24. So then, let's see what that gives us. We're going to do this next. And we're going to multiply 1,500 last, guys, okay? So 1.004 to the power of 24, which would give us 1.105, okay? We're going to times that by 15,000. 16,508.22 dollars. So that means if I invest 15,000 with this deal that the bank is giving me, I would do 16,508. This means that I would make 1,508, 22. It's up to you if it's worth it or not. If it's compounded. It seems like a deal, but in 2 years you're making $1,000. So if you have the money, it would be a good investment. But I'm sure over 15 years it'll be more. And and if you put more, you will earn more. And that's how the investments work. Number 3, the population of a town is decreasing at 3% per year. In 2000, there were 1,700 people. Find the population in 2012. All right, so in this case, the population of a town is decreasing at 3% per year. So decreasing is our key word right here. So we're going to be using exponential decay, okay? The difference between exponential decay and half-life, we're dealing with two different comparisons, two substance comparisons. With exponential decay, it's just one that we're dealing with. So y equals a 1 minus r to the power of t. Okay, so the population of a town is decreasing at 3% per year. In 2000, there were 1,700 people. Find the population in 2012. Okay, so same values here. My initial amount is 17,000 people. So 17,000. Nope. 1,700 people. Okay, and it's decreasing 3% per year. So my rate of decrease is 3%. I'm going to divide that by 100, so it's going to give me 0.03. In 2000, is when this number was given. So it wants you to find the population in 2012. Now, it doesn't tell me how many years, but we can do the math. From 2000 to 2012, that means that that's 12 years. So we want to find what the population is going to be like in 12 years. So, let's plug it in. Y is our unknown. We're going to have our initial, 1700. 1 minus 0.03 to the power of 12. Okay, we have one unknown. It's a good sign. So let's start again with here. 1700. Did I do that right? And then, oh, sorry, we don't do the decimal. First we're going to do this, 1 minus 3, and then we're going to do to the power of 12. So this means that we're going to have 1700 times 0.69384, okay? Then I'll multiply by 1700, which would give me 1,179.5. Well, we're going to round that to 80. Remember, these numbers represent everything. These two just happen to be money, so I put the dollar sign, but this represents people. So that means in 12 years, the population is going to go from 1,700 to 1,180 people. Because in this particular town, there is more deaths than there are births by 3%. So that's actually a big change in 12 years to drop that much. And that's important when you're building schools or when you're the federal government trying to see how much money a town needs. So all of this information is stuff that you probably haven't dealt with yet in the bigger scheme of things, but they're very important to know. So please make sure to write this down. Try page 639, numbers 3, 5, and 7. 3, 5, and 7. 639, numbers 3, 5, and 7. I will see you in class.